Welcome to Kennedy DIY. In today's video, we're going to take this circuit schematic and turn it into a flashing LED circuit. Let's go. So while there is a full parts list and links to components in the description, kind of go through what you need for this circuit. So you need two 470 ohm resistors. You'll need two 47K resistors, two 10 microfarad capacitors, two LEDs of whatever color you'd like, and two 3643 NPN transistors. To start, you're going to take your 470 ohm resistor and place it in your breadboard. Your next component is going to be an LED. An LED has two different length leads. The longer one is going to be your positive lead or your anode. The smaller one is going to be your negative lead or your cathode. An easy way to distinguish the two is to take the longer lead, the anode, bend it out slightly like this, so it's easy to tell them apart. Now, you're going to take that anode, the positive lead, and you're going to connect that directly to the second lead of your resistor in the same vertical line. Your next component is going to be your 10 microfarad capacitor. Same concept as your LED, it'll have a longer lead and a shorter lead. The longer lead is your anode. The shorter lead is the negative, or your cathode. It'll also indicate by a dashed line on one side of your capacitor. Connect the positive of your capacitor to the negative of your LED, and then you're going to put your negative somewhere in the middle of your breadboard, and then that negative of your capacitor will connect to the 47K resistor. So you put that in the same vertical line, and the end of that will connect in the same lead it started at. Now the nice part about this is this circuit is essentially the same thing on both sides, so just do it once and then do it again on the bottom rail. Next will be your transistor. So in order to tell which lead is which, the flat side facing you, the emitter will be on your left, the base will be in the middle, and your collector will be on your right hand side. So when you're taking a look at your breadboard itself, you want the emitter to be on the left hand side, again the flat side facing towards you, so we know the emitter is on the left, base is in the middle, collector is on the right. Add in your second transistor to your board, making sure that they align in the same vertical lines. Now, in order to distinguish between my connections, if I'm looking at my schematic and then I'm looking at the actual schematic diagram of a transistor, I can see that there's three different leads that I can distinguish between. So if I'm looking at my schematic here, the one with the arrow is going to be what's known as your emitter. The one with the line through the center is going to be your base, and the one with essentially no distinguishing characteristics besides the angle is going to be your collector. Now with all that information in mind, I can start to make my connections. First and foremost, I'm going to bridge the gap between my top and my bottom rails in order to ensure that power can flow between them in our parallel circuit. Now what I'm doing is I'm taking my connection between my LED and my capacitor and connecting that to my collector, which is going to be the right handmost connection on my transistor. I'm going to do the exact same thing on the bottom as I did on the top. Now, based off my schematic, I know that one side of my connection between my resistor and my capacitor, the negative side, is going to connect to the opposite side transistor. This is what gives me my flashing LED effect. So I'm going to take one side connection and make sure that it's connected to the opposite side transistor's base, not the same side. And again, I'm going to do the same thing I did on the top as I did on the bottom, connecting my resistor and capacitor junction to the base of my opposite side transistor. Last but not least, I can tell that my emitters are going to be connected together based on their location in my schematic. So what I'm going to do is I'm going to make sure that they are connected together, bridged with a single jumper wire. And lastly, what I'm going to do is I'm going to take a wire, place it in that same vertical line, and then I'm going to use that wire to allow my connection from my power supply in just a little bit. Now don't mind me as I spend a little too much time trying to figure out where the heck I want this wire in the camera frame. Now that my circuit is assembled, it's time to test. I'm taking the red wire, my positive wire from my power supply, connecting it to my first resistor, and the negative of my power supply, the black wire, to that cable we just placed in earlier. Set my power supply to 7.5 volts, turn it on, and see that my circuit is working correctly as my LEDs flash back and forth between the two separate colors. Now, it's pretty easy for me to change the speed at which they flash as well, so I'm going to take something like two 1K resistors and maybe a 22 microfarad capacitor. And when I connect those together, you can see how my circuit differs. It takes longer to charge the capacitor, therefore the red LED stays on longer and has more charge. So when you're looking at how this circuit itself works, the two components you need to pay close attention to are the capacitors and the transistors. So essentially, if you look at LED 1, for example, one of the things you'll notice is that it's connected to both capacitor 1 and transistor 1. But there's also a connection between the capacitor 1, and transistor 2. So essentially what happens is as the LED flashes, what happens is it discharges the capacitor, which essentially tells the transistor that it's time to turn off. The transistor acts as a switch. As the transistor switches off and the capacitor switches off, it essentially charges the other capacitor. So then you get that effect, right? That capacitor acts as the battery. So once one battery is discharged, the other battery charges and lights the LED. And then vice versa, continues to go on. Again, the switch is the transistor, the battery itself is the capacitor, which lights each LED in turn. If you enjoyed the video, please consider liking and subscribing. And if you have any questions, please reach out and I'll be happy to help you as best I can. Thank you.